Hello, everyone. I am João Almeida, and I am assistant professor at the University of Aveiro. I also work as a chief in information security office. This part is not so public, but you find it on LinkedIn, so you publish in the network. It's okay. And thanks to that, I have some resources to play a bit with large language models. So, next slide. Um, well, my participation in Eden, Eden is a project, for those who don't know, that aims to, well, I will try to summarize in a few sentences, but it aims to build a European network of OMOP-CDMs databases. And I participated in the Eden portal, and one of the main questions that try to answer is how to find the data and how to find the most suitable database for our study. Next slide. You need to double click, maybe, again. And in the Eden, we create the concept of database fingerprint. This one. In the database fingerprint is a process in which the data custodian needs to publish some information about the database. This part was built in two stages. In the beginning, we create a database catalog in which the data owner could fulfill a questionnaire with information about the databases, namely the contact and the type of databases, publications, and something very, very generic about the database. It was enough to know that the database exists, but well, with that information, the researcher could not know enough about the content, so we cannot decide if the database is suitable for a study or not. In the next stage, we created what we call the network dashboards, in which we ask the data owners to upload a file that is very similar to the Achille results, but with less information. Is a R package that we call catalog export. This extracts almost the same information as Achilles, but with less detail. And then we are able to build a set of dashboards so we can compare these databases. Why is this important? Well, this was an important part to obtain information for fulfill a large language model or information retrieval model. It depends of the part that I will present, but this information was the base knowledge for these models. So 2 slides, please. Sorry, it's easier to jump to the next two. Yeah. So the overview of the chatbot is to help discover with that information and using the Eden network dashboards data, which databases are better for a study, and we can easily find if or the study we are trying to do has data to support it. Currently, we have 200 databases in the portal, so it becomes very difficult to compare them and to find the suitable one. So for that, we propose the information retrieval model based on BM-V25, and with this we can obtain the most databases suitable for that study. This can be solved with a simple web interface, but we decided to integrate this in the chatbot so we can have some kind of communication between the user and the system. And if the user wants to have provide more information, like I want to make a study about this topic and about this topic and about other topic, the system can aggregate all these concepts and try to figure out which databases provides more concepts or more records about those concepts, this researcher. The part of the large language model that I will explain next is more related to the second part of this work, but it also helps us to understand the questions that the user does in the chatbot. Instead of using the old classic natural language processing models, we rely on the large language model to process the conversation and try to extract the information that we need to populate the background system. Next slide, please. Sorry. So the technology that we used was the model BM25. This was used only to extract the databases. We populated this model with information extracted from the catalog export package. We treated each concept as a document. This is a information retrieval model based on documents. So we treated each concept as a document. Then we tried to rank these documents and that are the concepts, and based on the number of records for each concept, we sum them for each database, and then we were able to prove it or suggest the most suitable one. About the large language model, we use the Llama 3 70 billion tokens. This was used mainly to create a fluid conversation, so we don't have like a static conversation, and also to extract the information from the users. Now I will present some shots from the system instead of presenting a video. Please, next slide. I don't know if I can switch them. Yeah, when we in this view, we can see this is a part of the view, the beginning. We say to the chatbot that we want to perform a study. He analyze the user in an orange part. The chatbot is the gray part. So we started saying that we want to perform a study, indicating which is the goal of this study. So we ask for help. The system tries to propose the most suitable databases, and before we continue, we can check these three databases are bottoms. If you change the slide, we can see that inside of each option, we can see more information about the database. Okay, let's see, and we can see I cropped this figure, but we have some information about the number of records available in the concept browser for each database, so we can confirm if these proposed databases are suitable or not for this study. I'm not sure if at this moment, if we ask again to the chatbot, he will answer these databases. But at the moment that I take this screenshot, the database that he proposed were these ones. So please, next slide. We then figure out that we could do more. So we have the concepts that were suggested, but we didn't present them to the user, but we have them from the background side. So we decided to do a little more, maybe ask the user if he wants to define the concept set. So the chatbot shows this view proposing a concept set, and the user can select those that are from his interest. And I will ask to click 2 times to pass the animation and show the next slide. And we can select the ones that we don't have, because the first column is about the ones is like the chatbot suggests these ones, but I don't. They are wrong. And the next 3 columns are very similar to the columns that we can see in Atlas, so it's almost the same. Then we can extract this, download, and upload in our own instance, or send directly to Atlas. In this case, I was preparing a demo for Odyssey Symposium in Europe, Rotterdam, and I connected my chatbot to the Odyssey demo Atlas. And if nobody deleted, this is still there and was created with a chatbot. I don't know if it's completely right, but it seems okay. So we can, using this conversation-like interface, create the concept set. Then the next slide, we can see the next part of the work in one more, in which we try to define the cohort. Well, we were very enthusiastic at this part, but we quickly find that define the concept set is much more easier to do than define the cohort due to the number of parameters. So we stop in the beginning, in the first parts, we are able to define the observation days, which is very simple to do on Atlas, but we also associated to the concept set to this cohort using the chatbot and then send this information to Atlas. Just one slide. And this is available like a template on Atlas, and we are trying to figure out how to improve this part. One more slide, please. Sorry. Yes. Cohort entry, we are able to do the co-entry events, entry events. These were extracted from the chatbot, and when we're trying to explore more, well, this is a very recent work, this last part, the cohort definition, but I received some feedback. Initially, we did this just, I don't want to say just for fun, but was like a bit just for fun to see how we can manage and integrate this with Atlas. But we were more willing to explore the databases and the finding the data that we have about the databases, so we can simplify the discovery of databases. But the feedback that I received on the Odyssey Symposium was that people that are not very used to use Atlas love this part of chat with something that then converts the data into a template on Atlas. So we are now trying to create more information to put on Atlas. One more slide and I'll explain how we get this. We create a JSON structure that have some questions. These questions are sent to the large language model. For instance, I gave an example in the next slide about the prior days. We have these two sentences, is a question and a sentence, and then we send this to the large language model, and the user gives the answer. We use reg, and the user provides the answer, and then we validate this answer until this is one of the available options. While the user does not answer properly, the large language model is proposing new questions until get answer for this question. When we get the right number for prior days, then we skip for post days, and so on. Well, we were able to, with some effort, to get here, but we are trying to find which will be the next step, since build a full cohort on Atlas using a chatbot I think is very complex. We are studying the best solution. This is the current state of the work, and we aim to put more effort on the chatbot and less effort on Atlas. So a user, when gets on Atlas, can use it like, okay, I already filled this, so let me check if everything is okay, and if it's okay, the study can be conducted. And I think my next slide is what we are proposing to do on ongoing work, that is mainly to have the most effort on the chatbot and the less effort on Atlas. Thank you. I'm sorry for the slides. If you have any questions, I would like to answer them. And if you have any suggestions, I would love to hear them. Thank you.